Imagine standing on the surface of Mars at 3 in the morning, under a sky so cold and thin it would steal your breath in seconds. The rust-colored ground is completely still. There is no wind, no sound. The stars above are sharper than anything you have ever seen from Earth. And then, from somewhere beneath your boots, something is exhaling. That is not a metaphor. That is quite literally what NASA's Curiosity rover may have detected inside Gale Crater. A gas rising from the Martian soil at night, faint but unmistakable, only to vanish again by morning. The gas is methane, and its presence on Mars has ignited one of the most captivating, maddening, and genuinely unsettled debates in the entire history of planetary science. To understand why this matters so deeply, you have to appreciate what methane actually is. On Earth, roughly 90 to 95% of atmospheric methane comes from biological activity. Microbes in swamps, bacteria buried in ocean sediments, living organisms breathing out this simple molecule as a byproduct of metabolism. Methane is, in a very real sense, the breath of life. But methane can also arise from purely geological processes. Water reacting with iron-rich rocks deep underground, in a chemical reaction called serpentinization. Heat-driven chemistry between carbon dioxide and hydrogen. These pathways require absolutely no biology. So when scientists discovered hints of methane in the Martian atmosphere in the early 2000s, the scientific community did not quietly file it away. They leaned forward. Because finding methane on a world considered barren for billions of years means one of only two things. Either Mars is geologically more alive than we thought, or something is actually alive. The first serious detection came in 2003, when astronomers using telescopes at the Keck Observatory and NASA's Infrared Telescope facility in Hawaii identified 3 spectral absorption lines in Martian light that collectively matched the chemical fingerprint of methane. The announcement was careful, measured, and electrifying. Then came Curiosity. Launched in 2011 and landing inside Gale Crater in 2012, this car-sized rover carried an instrument called the Sample Analysis at Mars Laboratory, or SAM. SAM included a tunable laser spectrometer, an extraordinarily sensitive device designed to detect trace gases in the thin Martian air. In November 2013, something unexpected happened. Curiosity recorded a dramatic 10-fold spike in methane concentrations. The team ran the numbers again and again. Readings showed methane surging to nearly 7 parts per billion by volume. Scientists at NASA's Jet Propulsion Laboratory, including Curiosity's science chief John Grotzinger from Caltech, were cautious. These were extraordinary measurements demanding extraordinary scrutiny, but the data was striking. And then, just as abruptly as they arrived, the spikes vanished entirely. This pattern became the signature of the Martian methane mystery. The gas appeared, sometimes surging to 40 times the baseline, then disappeared within weeks. It was stronger at night and faded during the day. It shifted with the seasons. The behavior was so erratic that Ashwin Vasavada, Curiosity's project scientist at JPL, later described it as a story with a lot of plot twists. By 2018, NASA announced findings that deepened the puzzle further. Curiosity had not only detected methane fluctuations, it had found complex organic molecules preserved in billion-year-old Martian rock. Molecules containing carbon and hydrogen, the same building blocks underlying all life as we know it. The organic material itself was not proof of life. Organics can arise through purely chemical processes. But finding them alongside mysterious methane made the picture far more layered. The next question was whether any orbiting spacecraft could independently confirm the methane from above. That became the mission of the ExoMars Trace Gas Orbiter, a joint project from the European Space Agency and Roscosmos, which began detailed observations in 2018. It carried 2 of the most sensitive spectrometers ever sent to another planet, purpose-built to hunt trace gases at concentrations far below anything previously attempted. Scientists waited eagerly. The trace gas orbiter detected nothing, no methane, 0 signal. This was profoundly confusing. The upper limits its instruments established were more than 10 times lower than the weakest detections Curiosity had reported from the surface. The contradiction was stark, unresolved, and deeply unsettling. Some scientists proposed that Martian methane might be destroyed extraordinarily rapidly by ultraviolet radiation, vanishing within hours before spreading upward into the wider atmosphere. But this would require a destruction rate far faster than any known atmospheric chemistry allows. Others suggested a geographical argument. Perhaps the methane was extremely localized, trapped near the floor of Gale Crater in such thin pockets that an orbiting spacecraft, averaging measurements across vast regions of sky, would simply miss what a rover detected at close range. Then came a fascinating new piece of the puzzle. A study published in JGR Planets in March 2024, led by planetary scientist Alexander Pavlov at NASA's Goddard Space Flight Center, proposed a striking mechanism involving perchlorate salt, a compound widespread across the Martian surface. The idea is this: methane produced either biologically or geologically, somewhere beneath the surface, becomes trapped under a hard, frozen crust of perchlorate salt within the Martian soil. When temperatures rise during warmer parts of the day or warmer seasons, the salty crust begins to sublimate, weakening and allowing trapped methane to pulse upward in brief bursts. That would explain the nighttime peaks and daytime disappearances Curiosity recorded. Pavlov's team raised one more possibility that is both fascinating and slightly humbling. The weight of Curiosity itself, rolling across the regolith, might be physically cracking these salt seals. The rover may have been inadvertently generating some of the methane events it was trying to study. But here is where the story takes its most extraordinary and unsettling turn. In early 2025, a team led by Dr. Sebastian Viscardi of the Royal Belgian Institute for Space Aeronomy, working alongside researchers from the University of Washington and NASA Ames Research Center, published a reanalysis of Curiosity's methane data in the Journal of Geophysical Research, Planets. Their conclusion was stunning. The methane Curiosity detected, they argued, may never have been Martian at all. Their analysis found that the four-optics chamber inside the TLS instrument, a compartment adjacent to the cell holding the actual Martian air sample, was contaminated with methane at levels at least 1,000 times higher than what the sample cell was supposed to contain. This contamination likely originated from terrestrial air that entered the instrument before Curiosity's launch here on Earth. Despite repeated attempts to evacuate the system, methane kept reappearing inside the instrument. Even more troubling, in most of the 5 published TLS detection experiments with publicly available data, only one of the 3 spectral lines being analyzed actually indicated methane. The other 2 showed nothing. Yet when scientists averaged the 3 measurements together, the result registered as a positive detection. Viscardi's team calculated that the probability of this specific pattern occurring purely by chance in every single experiment was roughly 1 in 1,000. To be precise about what this means, the 2025 study does not prove there is no methane on Mars. It raises serious, peer-reviewed questions about whether Curiosity's specific instrument was reliably measuring Martian methane or partly detecting contamination from inside the rover itself. The 2003 telescope-based detections remain. The hints from ESA's Mars Express remain. The geological mechanisms for subsurface methane production remain compelling. None of those lines of evidence disappear because of one reanalysis, however carefully argued. What the 2025 paper does is remind us, forcefully and beautifully, that science is not a single triumphant moment of discovery. It is a continuous, self-correcting conversation between evidence, instruments, interpretation, and honest doubt. Viscardi's team even proposed a decisive test. A carefully designed sequence of 2 TLS experiments on consecutive Martian nights, keeping the same air sample sealed inside the instrument between them. This single test could clarify, more definitively than anything attempted so far, whether the detected methane truly comes from Mars or from within the rover itself. That test has not yet been completed. Mars is still holding its answer. Consider what rides on the outcome. If Martian methane is geological, it rewrites our picture of a world we consider geologically quiet, implying internal heat, water rock reactions, and subsurface chemical activity still at work today. If it is even partially biological, even pointing toward ancient microbes preserved deep in subsurface rock, rather than anything actively breathing, the implications stretch far beyond Mars. Life would not be an Earth-specific accident. It would be something the cosmos is inclined to produce wherever the right conditions assemble. The loneliness we feel when we gaze up at the stars would become, in the most beautiful possible way, a misunderstanding. Scientists have called for future surface missions, carrying instruments far more precisely tuned to atmospheric chemistry, designed specifically to avoid the ambiguities that have haunted these measurements for 2 decades. The answer is coming. It simply requires patience, precision, and the courage to keep questioning what we think we already know. Carl Sagan once said that extraordinary claims require extraordinary evidence. Martian methane has delivered extraordinary questions. The extraordinary evidence is still being assembled, one careful measurement and one honest reanalysis at a time. What you just heard is not a story about whether Mars has life. It is a story about how science works at its most honest and its most courageous. A planet 47 million miles away that has refused again and again to be simple. If that kind of wonder speaks to you, subscribe and share this video with someone who loves a great mystery. And drop your thoughts in the comments below. Do you think Mars is trying to tell us something? Because the scientists who have spent their careers listening believe the answer is still out there, waiting just below the surface.